Hello everyone, welcome to another video, and this time I want to show you two things. I actually did record a small video yesterday and I did show some part how you can use that ChatGPT, but then I actually wanted to use that in order to create some script which can transfer IFC elements to the Revit elements. And then when I did just show that part of the script, I did realize that I need maybe 1 hour more in order to create somewhat functional script. So this video will contain what I did record yesterday and this entire script, just for you to see that you can transfer the elements from the IFC to the Revit. So over here I did use some small sample file which I did use in my previous videos. I have a couple of ducts, a couple of pipes, a couple of cable trays, and what I will try to do in this video is to run the script in order to automatically get ducts which I did select, and I'm inside the mechanical metric Autodesk template. So for ducts I have following types. We will try to retrieve from IFC those rectangular elements, and before we even start the script to see how it works, it is very important for you to find from which IFC parameters you want to retrieve size. So for rectangular elements we will use those parameters. For round elements it is similar, its dimensions dot diameter, this parameter, but I did leave an option. If you have some different names, you can just type different names and it should work. So like in that script where we did use AutoCAD in order to create automatically cable trays, pipes and ducts, in order to create some element we need center line, and that is the biggest job in the script, because you cannot retrieve through the get location node the location of the element from the IFC. At least I was unable to do it. And before we create our elements, let's just set some system colors. So okay, supply has a blue, return okay, just to check if everything has a color. Yeah, it is. Okay, now we will run the script. So you can see that I didn't even set the name for the script, but I will change that when I upload the script. I was also lazy to set up some image, but it's not important right now. So we have a user interface with some amount of data that we need to set. So which duct type we want to use. If we want to select a round ducts, we will use some round type. If we want to select rectangular ducts, we will select rectangular type. For example, I know that those three types belong to the round ducts, so I will take these. The system, let it be supply air at level, let's say 1. And now in order for Dynamo to recognize what is the size of the element, you just need to check, like we did prior, that parameter name, and that's it. Set values. Yeah, and I didn't select the elements, so we need to go back. Sorry for that. So at first we need to select the elements. We need to click on the link. Okay, now from this link we want to pick up those two round ducts. Let's go again. It's the supply air level 1, and that is it. And now we have those elements. Let's just turn off the visibility of IFC for a moment. So let's check it is correct type, it is correct dimension, it is correct the system, and that's it. Okay, let's see what we will have for rectangular elements. The things which worries me a little bit is it is also for the Revit sometimes confusing what is the height, what is the width, but let's check. If it's okay, good. If not, we will just with a space, rotate that element. Run. Again, let's first select our elements. I did click on the IFC. Now I'm holding Control key. I did select those elements. Let's say some another system return here, for example, use the same level. What will be type? Let's say round elbow taps. That is okay. Level 1, we will use those parameters, set values. So we can see that this element has a correct location and size, and this element over here also, but this element is not correctly rotated. Again, inside the script we can detect if that is a good rotation or not. If you did see my last two videos, you can see that that is possible. I did already create that kind of the logic. This is just like a proof of case, just for us to see that we can retrieve those elements. But okay, we can rotate this element easily. Now I want to go to the script to show you the script. So okay, so we have three parts over here. User interface as always, part where we actually have that ChatGPT Python script which will determine the center line of the elements, and the part where we will create ducts. For user interface, I don't know if I have anything to tell you which you already didn't see in the previous videos. So we need to select elements, to choose the duct type, to select the system, to select the level, and also we need to know those parameters for IFC in order to recognize the dimensions. Everything will go to the multiple input form. A lot of these nodes over here will just be used in order to read information and to send that information to the correct nodes. And okay, let's run the script. Again, we need to select the elements, click on the IFC, click on those two elements, finish. Let's go with exhaust there, for example, level 1. Now let's go to tabs. Previously I think we did use the T's, and the parameter name is the same. Okay, let's now follow the results inside the Dynamo. So we took just two elements from that IFC. We did convert those elements to surfaces. I will show you now that video from yesterday. I did want to try to go immediately from surfaces to the center lines, but this ChatGPT was unable to create that in a way which is acceptable through Dynamo. Did call some Python libraries which this script don't have. I did check some of those libraries that the ChatGPT did call. We did have over here in the zone before everything else, but that still didn't work. It's okay. For me it was easy to switch from the surface to the center point of the surface, so I did deliver that as an input, and from there I will now show you the video how I did retrieve this Python script. Over here we have some round ducts, and what is like the first step? The first step is to find the center lines for those elements. So in Dynamo I did call the node to select the elements from the link file. I will convert those elements to surfaces. From surfaces I will try to find the center points for each surface, and that I will deliver to the Python script. And so we did pick up the surfaces. Let's show. We have those ducts over here. Then we have a point, and over here I have this Python script. So this Python script will automatically find the center lines, and this is the code. Now I didn't write this code. I did use that ChatGPT OpenAI website, and now I did start from here, and I did mention that we have a sublist, so you will select multiple installations. If you do not mention that, then what the Python will find, it will find the longest line. It will find the longest line. So if you do not say that you have sublist, you will have either this line or the other diagonal line. So you must say that you have a sublist, and in this case Dynamo did find only one line, and then I just did add give me the longest line for each sublist, and then I did retrieve this code. I just did go copy code, I can show you over here. I did copy, I didn't change anything, and then I did go to the Python script, select all, paste, run, and as you can see we have over here our results. Now now to check the rest of the script. Now when we have those two center lines for our elements, now we need to read, we are dealing with diameter, so we did read what is the dimension of diameter from that from those IFC elements. Over here we have just some if else and while loop which will check if those dimensions over here have a number or not. If we have a value, then over here we will take those lines and send to the node. If we don't have the value as over here, we will have a false, and that false we will deliver as a line. Why? Because when I did use, and let's also annotate what I did use over here, again the same that is cute, the same nodes which I did use in the AutoCAD to the Revit script. So MEPover node will create the elements, duct, pipe or cable tray, even if you don't deliver over here dimensions. So if you just by default send those lines to both nodes, it will create some elements with random dimensions. So it is a good thing to filter out those elements prior to sending those lines. I did just create some small script. You can do with else, you can do with if node, but it is the same basically, and basically that is the entire script. So again, now when I did turn on the monocle annotate, we have a couple of nodes from MEPover, and we have a lot of different nodes from the data shapes in order to have a user interface. Over here we have GeniusLoci in order to collect all the levels, and that's it. Thank you for watching. Bye.